In this lab, let's take a look at the spatial joint. So with a spatial joint, an object has 6 degrees of freedom. That is, it can move anywhere in space. So these objects can translate along the X, Y, or Z axis, or they can rotate around X, Y, or Z axis. So we'll go into dynamic simulation and we will go ahead and play the motion on these components. We'll also look at how to put traces or curves that follow the motion of the objects. And we'll look a little bit more at using the simulation player. Now the first time through, it's doing the calculations. So again, the calculation speed doesn't necessarily match the real time. So this was 1 second of real time. It took 25 seconds to calculate that motion. Once it calculates it once, we can play it again and it will play back faster, but then again it doesn't play real time. Later on we'll see how we can export this or publish this to Studio, and then we can set it to real time. So we will click publish to Studio, and we'll do additional operations on future labs. So let's look at how to set all this up. Let's start a new inch part file. So I'll select standard inch IPT. I will go to the top view and I will start a new sketch on the XZ plane, and then I'll do a center point rectangle, and I'll dimension the width of this as 6 inches and the height of it as 3.375. I'll then put a fillet on the corners, and for the radius of the fillet I'm going to do 0.625, and I will select these two edges, these two edges, these two edges. I'll then offset this, so I'll do offset it, and I'm going to offset it, and I'll dimension that offset distance as a distance of 0.156. I'll finish that sketch, and let's go ahead and save this. I'm going to call this GMO table, and then I will do extrude, and I'm going to extrude this portion at 0.125. I'll make that sketch visible again, and I'll do extrude again, and I'll extrude this area in between those two, and I'm going to extrude that at a distance of 0.5. Now you could change the color of that if you like. I'm going to change mine to blue. You can use whatever color you want, or you might put some material texture on here, like perhaps wood. I'll turn off the visibility of this sketch, and I decided actually that I would like to make this face the same as the top plane rather than having the top down here. And so I'm going to edit that first feature, and I'm going to also include in the profile this area, and I'm going to flip that direction so that it's going down. So I have all of the profile selected going down, and then I have just the outer profile going up. And so now this plane is up here rather than down here. Just a preference for later on. Then I'll start a new 2D sketch on this top face, and I will project geometry. Now I've turned off auto projection of geometry. Under Tools, Application Options, on the Sketch tab, I turn off these grid lines. I turn off the auto project edges during curve creation. I do leave on auto project part origin, and I bring this opacity of sketch through shaded model. I bring that up to a higher value. Alright, so I'm going to then do project geometry on the Sketch tab, and I'm going to project this line right here. I'll project this line, and I'll project this line. Say okay to that. Actually, let's project these two arcs as well. So I'll project this arc, and I'll project that arc. I'm going to change though these two lines to construction, so I'll change those to construction, and then I'm going to draw a 2-point rectangle from here up to here, and I'm going to dimension the width of this rectangle as 1.725. And then I'm going to change that rectangle to construction as well. So I'll select that, change that all to construction, and then I'll draw a line from here over to here, and a line from here over to here. Finish that sketch. I'll then do a sketch on the XY plane, and I'm going to project geometry this line right here, and I'll draw a circle at that projection, and I want to make this circle coincident to this line. So I'll do project geometry, and that projects that as a point, and then I can do coincident between that point and this circle. So that circle is fully defined. I'll then do a sweep, and I want to sweep this circle along this path, but it's not allowing me to select a circle, and this is actually an issue that we'll have to watch out for. The last sweep that I did it as a solid sweep. I don't want to do a solid sweep. I'm going to come down here and tell it now new solid, and I want for the curve, I want to get the sketch, and it's trying to pick the edge of the part, and so I'll need to get this sweep path, and it goes that distance, and I also need to get this line underneath there, so I'll get that curve, and I need to get the line under here, and so I'll get that curve, and I've set this then to do it as a new solid. I'm going to change the color of that new solid to some other color, and I will select this sweep feature, and then I'll come up here to my color wheel, and I'm going to select a color. Right, then I'm going to do a fillet on this edge, and I'll do a fillet on this edge, and the radius of that fillet 0.125, and I want to match that color onto those ends, so I'll pick up my color, and then I'll come over here and select that fillet, and that puts that same color onto those ends. I'll then mirror this to the other side, so I'll do a mirror. I'm going to mirror this solid body. I'll select this solid body, and I'll mirror that about the YZ plane. Alright, you could do some additional adjustment with color. Technically, we have these two parts interfering with each other. You can fix up those solid bodies if you like. Subtract this solid body from these two, keeping the original tool body. I'll save this. Alright, then I'm going to start a new metric part file, and it doesn't really matter whether we do metric or inch, but I'll do a new, and I'll go to metric. I'll do a standard millimeter IPT. I'll start a new sketch on the XY plane, and I'm going to do a 2-point rectangle at the origin, and then I want to make the height equal to the width. So I'll do equal this height equal to the width, and then I'll dimension this, and when I dimension it, I'm going to call this, I'm going to give it a variable name, so I'm going to call it cube equal 25 millimeters. Now I'd like to see the name of that variable, so I'll come down here and I'll select expression. I could either do just the name or the expression so I can see the value, and then I'm going to draw a circle at the center point, and I'll dimension it. I'm going to right click before I place the dimension, and I'll go to dimension type radius, and so that will place that dimension as a radius, and again I'll make that I is the variable name, and I'll make that equal to cube divided by 10. So if I change this cube size, the size of the circle will always be 1/10 of whatever I change that cube size to. I'll finish sketch, and then I'll do extrude, and I'm going to select cube. I'm going to set it to midplane, and for the distance, I'm going to set that distance equal to this variable name through that midplane as variable cube. I will change the color of this part, and I'm going to make mine yellow. You can make yours whatever color you like. I'll turn on the visibility of sketch number 1, and then I'm going to do extrude again, and this time I'm going to select inside that circle, but I don't want to extrude all the way through the part. I want to extrude from this face, so I come over here to sketch plane. From this face I want to do cut, and I want to cut that distance, and I'll highlight that value. I'll cut that list parameters the distance I. I'll then turn off the visibility of the sketch. I decide I want to add a fillet before I do this feature, so I'll drag my end of part marker up, and I'll do fillet, and I'm going to set this as list parameters the I variable, and I'll tell it the entire feature, and I'll select that extruded feature, and so that puts a fillet on here, and then I'll bring this back down and we see this feature again. I'll do a second fillet, and I'm going to select this arc inside here, and I'm going to make that the radius I, and I'm going to change the color of that fillet, so I'll go to properties, and I'm going to set this as black. I'll save this, and I've already done this once. I'm going to call this GMO potato. So we can't play games. Let's imagine that we're going to pack potatoes into a box. If we could genetically modify that potato organism so that they all grow as square, then we could get more into a box as we're packing those. Unfortunately though, we're able to get it as a square or a cube, but we weren't able to remove the eyes from the GMO potato. Alright, let's do a rectangular pattern. pattern, and I'm going to select the eye and the extrusion. Then I will set the direction as the X direction. I want 3 copies, and then for the spacing I want that as, we'll call this pitch. I'll name this pitch, and I'm going to make that equal to, and we'll click here for list parameters, cube divided by 4. I want that mid-plane. We can see the preview, say OK to that. I'll do the rectangular pattern again, and this time I'm going to select the previous rectangular pattern, and for the direction I'll select the Y direction. Again, I want 3 copies, and I want this as pitch, and I want it mid-plane. I will then do a circular pattern of this going around, and so I'll do a circular pattern. I'll select both of these rectangular patterns. Now notice when I select the last one, it selects all the children that make up that pattern. So sometimes we don't want to pattern a particular child. We could control unselect a child in some cases. All right, I'm going to pattern this around the Y-axis. I want 4 copies. And so now we see that we have patterned those around the 4 sides, and then I want to pattern it the other direction. So I'll do a circular pattern again. I will select this rectangular pattern, and for the rotation axis I'll rotate that around the X-axis. I want 4 copies, and we'll say OK to that to pattern it around that side. Now to change those colors, I'm going to go to the eyedropper to pick up, adjust the color, and can drop that with the paint bucket, hold down the control key on these patterns, and we'll click OK for that. Okay, so there's our front view. And then we need to remove the eyes that are not appropriate. Okay, so if this is our front, I'm going to move the front about like that. And then I want to put 1 eye on this location, 2 over here, 3 over here, and so forth. So I'm going to go to delete face, and I'm going to delete all of the other eyes except for the one in here. And we saw on the previous lab, then we need to tell it to heal the remaining faces. And then on this face I want to leave 2, so I want to leave this one and this one. So I'll delete all of the eyes except for this one. I accidentally got this face, so I'll control unselect that face, and then I can get that one. And you might want to check this once in a while, so I'll go back then and I'll edit that feature again. And then on this one I want to leave 3, so I'll select those. So I have 3 on this side. So on this there are 4 on the other side to add up to 7, 2 and 5 to add up to 7, 1 and 6 to add up to 7. So I have 2 on this side, so I need 5 on the opposite side. So I'll edit that feature, and I will leave the 5 on this side. Okay, so 5 and 2 is 7, and I need 4 on this side. So let me edit that feature, and I'll leave the 4. Again, I accidentally hit the wrong face. Okay, so I have 4 on that side, and I have 1 on this side, so I need 6 on this side. So let me edit that feature. Alright, so that completes my part. I'm going to save that, and then I'm going to start a new metric assembly. I'm going to save this as Spatial Joint, and I'll place the table that we did, the GMO table. I'll right click, place that grounded at origin, and then I will place the GMO potato, and I'm going to just place that someplace up here. Now if I go back to this part, if I go to the parameters and we find that cube parameter, if I say change this to 20 millimeters instead of 25, or whatever value that I want, everything should update. I'll click the lightning bolt, the file size updates, or the cube size updates, and all of the eyes update. So then I'll go back, so I'll click that lightning bolt here, and it updates to the new size. Let's place 2 more of those. So I'm going to control select and drag another one, and I'll control select and drag a 3rd one. And then I want to rotate these a little bit so that they're not all oriented the same. So I'm going to click on free rotate, and I'll select one and I'll rotate it, and I'll select the next one and I'll rotate it, and I'll select the last one and I'll rotate it. So I've rotated these at various angles. I don't know what angles, but whatever they are. I'm going to move these a little bit closer so that they're lined up. I'm going to check it from a couple different orientations. So I look at it from the front view and to the right side view, make sure that it's over the table. This one I might move it over just a little bit. Then we'll go into dynamic simulation. I'll go to environments and I'll do dynamic simulation. And right now I see all of these parts are in the grounded group. So I want to add gravity to this. So I'll right click, I'll define gravity, and I want gravity perpendicular to this table pointing in the opposite direction. But if I go ahead and play it, because these are grounded, you know, they just sit there, nothing happens. So I need to add degrees of freedom to these three components. So I'm going to go to insert joint and I'll do spatial, and it asks me to select component number 1. I could select this component anywhere. I'm going to do some trials going forward where rather than selecting part faces, I always select the origin geometry. So I'm going to go to the assembly tab and I'll go to the table and I'll select the center point of the table, and then I'll go to my second component and I'll select the center point of the first potato. I'll apply that, and then I'll go back and get the center point of the table again, and I'll get the center point of the second potato, and I forgot to put it on second component, so I'm going to cancel that out and just start from the beginning. So I'll do insert joint, spatial, the center point of the table, the center point I need to put here on component number 2. That's what I forgot to do. Component number 2, I'll do the center point of the second potato. I'll apply that, and then I'll get the center point of the table, go to second component, and I'll get the center point of the third potato. If I click back here on dynamic simulation, we now see that those 3 potatoes have been moved out of the grounded group and are now in the mobile group, and we put the 3 spatial joints on there. If I go to the properties, I see that there are 6 degrees of freedom. There are 3 revolution degrees of freedom and 3 translational degrees of freedom. So it can translate along X, Y, or Z, and it can rotate along X, Y, or Z. So that's the spatial joint. Now I'll go ahead and play this, and we see that they falls right through the table because we haven't defined contact. So I need to insert joint, and I'll do a 3D contact. And again, rather than select the component faces, I want to select the origin geometry. And so I will go back to assembly, and I'll select the center point of the table, and then for the second component I'll select the center point of the component, and I'll apply that, and then I'll get the table again and the center point of the second potato, apply that, and then the center point of the table and the center point of the third potato, and I'll say okay to that. So now when we play this, we see that it falls down and stops when it hits the table, but the potatoes still go right through each other. So we also need to put 3D contact between the potatoes. So let me stop this. I'll rewind it, go back to construction so I can make changes. I'll save it, save often, and then I'll do 3D contact between the potato 1 center point and potato 2. Apply that. Let's move this over here. Between the potato 1 and the potato 3, I'll apply that, and then between potato 2 and potato 3. Say okay. Click on dynamic simulation, and I'll band this so I have the 3D contact with the table and the potato 1, table potato 2, table potato 3, and then potato and potato 1 and potato 2, potato 1 and potato 3, potato 2 and potato 3. I'll then play this. And we see that they come down in contact, and then when they contact each other, they cause each of the components to move. Now I have it set to do 1 second and 100 calculations within that 1 second. So the animation time does not match the calculation time. So we're coming up on 50 seconds to calculate 1 second of animation. Later on we can publish this to Studio, and we can set it then to a true time period. Because we're calculating more than just the kinematics or the motion, we're calculating gravity, friction, forces, accelerations, velocities, dozens and dozens of variables we are calculating in the background. It takes it longer to do this than real-time motion. I'm going to go ahead and stop this, and I want to change this to do, say, half a second calculation. So I'm going to rewind, and so we always have to go back to construction so that this isn't grayed out, and then we can make a change. I'm going to do half a second, and I'll hit tab key, and I'm going to do 50 calculations. Now I want to get a trace or a curve of the motion that these are making. So I'm going to tell it to insert a trace, and I'll go back to the assembly tab, and I'm going to put my first trace, and I can just display the trace, or I can put this into a spreadsheet or a file that we can use later on. So we'll use this column later on, but for now we're just going to do the display trace of the trajectory, and I'm going to select the center point of the first potato. We see that it's highlighted there. I'm going to change the color of this one to red. I'll apply that, and then I'm going to pick the center point of the second potato, and I'm going to change this one to the trace to green. I'll apply that, and I'm going to select the center point of the third potato, and I'll change this one to blue. Say OK to that. And now when I play this, we'll see that it calculates the position and gives me a curve of the position of the center point of each one of those components as they move. So I did a half a second of animation or simulation, and it took 48 seconds to do the calculations of 50 time steps within that half second of motion or simulation. So that is the spatial joint.